Hello, my name is Michael Endres, and I'm here to talk to you guys today about graphene and its applications. Now, since its discovery in 2004, graphene has been a topic of discussion across the technological industry. Its wide range of potential applications have many researchers promising that we will see graphene in the future. Now, to define graphene, it is a single atom layer of graphite or carbon arranged in a hexagonal lattice structure. Now, graphene is a great electrical conductor, better than copper, they say. It's a great thermal conductor. It's 1,000,000 times thinner than paper, stronger than diamonds. It's transparent, flexible, and also hydrophobic. Now, with these properties, researchers have been looking for ways to incorporate it into our everyday life, replacing materials or even sparking new technology. I'll be going through some more relatable applications and explaining the properties in accordance to its proposed use. So we're going to start with probably the most simple way to apply graphene, and it's enhancing composite materials. So if you've ever seen a piece of manufactured lumber, it's PVC, that would be a composite material. And by adding sheets of graphene in the production process, you will be having a composite material with sheets of graphene inside, rendering it properties of graphene itself. So it would be stronger, be flexible, it would be electrical conductive, thermally conductive. It would all be at the cost of a atom's thick layer of graphene. A Chinese company has also made a polymer infused with graphene. So this is a plastic that can be molded like any other plastic, but now it is rendering the properties of graphene to enhance the material. Graphene has also been infused in paint. So they have paint that can be applied to ships, cars, firearms, and it'll protect it from rust 100%. It's a very, very strong material, making it a perfect candidate for a durable paint. A more relatable application we hear is the uses in smartphones. Graphene has been applied to batteries and the touchscreens on smartphones. So the current battery that you have in your smartphone is called a lithium battery, or there's a couple different batteries out there, but the processes are all the same. From charging and recharging, using the energy and recharging it over time, it will actually deteriorate the battery, leaving it to be holding less charge and charging slower. Researchers have essentially sandwiched your battery with graphene sheets. Now this will create like a very hard outer layer that will be electrically conductive and also be thermally conductive, giving off all that heat that's being produced, and also increasing electric flow, meaning a quicker charge, quicker usage when needed, and also it will hold more it will hold a consistent amount of power. On the topic of batteries, graphene has also been used to develop capacitors, but not just a capacitor, a supercapacitor. A capacitor is much like a battery, except they hold a certain amount of energy, but they can be charged very, very quickly. A supercapacitor can hold a ton of energy and also be charged very, very quickly. I read an article with research going into creating a supercapacitor battery for your smartphone. So imagine a battery that will last a week and it will take 30 seconds to charge fully. That seems like a very, very demanding product. Samsung has already developed a prototype for a graphene screen. It's completely flexible. You can bend it any way you want, and it's durable. You can't crack it because it's not glass. And this technology has been around for a while, and Samsung just came out with this, and we should hope to see more graphene screens in the future, because we can all see how having a crack-proof screen may benefit us in some situations. Graphene has also been applied to solar energy. It's a perfect candidate to be a solar cell, because solar cells are required to be transparent and a great electric conductor. and graphene is both of those. So they've been researching for ways to use graphene to make solar cells and solar panels. It'd be a very durable material. It'd be a great absorber of light from the sun energy and transferring it to the transformer. However, they mentioned graphene by itself isn't such a great use for solar energy. They modified it to graphene oxide, which allowed it to transfer energy very efficiently and also absorb the sun's energy, although it does lose a little bit of transparency. Nonetheless, it's also been looked at to replace the current materials used in solar panels. The current material used is indium tin oxide, and this is used in concordance with a glass layer as well. And it's very brittle and it's very, very fragile. And also, indium tin oxide is not very common. It's a pretty rare material, and sustainability for this isn't seen to be very long. But graphene, on the other hand, is made of carbon, and we have an abundance of carbon on planet Earth. We've also seen ways to apply it to water filtration. Now, because graphene is naturally hydrophobic, it is repelling water, so that's what that means. And graphene has been modified to allow nanoperforations to be made, allowing water molecules and only water molecules to pass through, halting viruses, bacteria, or any other debris or contaminants that you don't want in your drinking water. It's also been researched to create an allotrope. I think this was a Chinese company. They also developed an allotrope of graphene called graphene, and an allotrope just means that it's in a different formation. It's not in the hexagonal lattice. And this has been used to put research into radioactive cleanup, but moreover desalination of water, turning ocean water or seawater into drinkable water. And the research has been showing that it is a very, very efficient compared to the current technology, and we would hope to see this further in development to create a feasible solution to a very real problem here on Earth. That's clean drinking water. So graphene has been dubbed the wonder material across the technological industry, and it seems to be a very, very promising material, seeing the many applications that have been proposed so far. Since its discovery, 2015, over 25,000 patents have been filed. That's almost 2,500 a year. That number alone shows that graphene has a future and that it will change the way that we look at technology. To help fuel the research and development of graphene, we must spread the knowledge and research more about graphene. It truly does show a promising future of the next level of technology.